Hello everyone. In this video, we will discuss our next topic, Cauchy Euler equation from second order ordinary differential equation. So first question is, when we have to apply Cauchy Euler equation? If the given differential equation, if in the given differential equation, the coefficient of the equations are not constant, okay? The coefficients are in variable form. Variable of x, okay? So if in the given differential equations the coefficients of the derivative term or of the dependent variable are not constant, in that case we can use Cauchy Euler equation. In my last lecture, that means when we have learned about complementary function, particular solution, and also method of variation of parameter, in all cases we have seen that the coefficients are constant numbers, okay? But today's topic is, here the coefficients are non-constant number. I am not touching the theory parts. I will explain this form, that means Cauchy Euler equation, or you can say Cauchy Euler method, using an example, okay? Properly, step by step, I will explain each steps. So let's start using an example. So first question, solve x square d2y dx2 plus 4x dy dx plus 2y, this is equals to log x. Here you can see that the coefficients are variable. They are x square, 4x, 2, etc. So obviously we cannot apply variation of parameter. We cannot apply the basic formulas of particular integral and complementary function. That's why here we have to use Cauchy Euler method, or you can say Cauchy Euler equation. Okay. How? Using Cauchy Euler method, first we have to convert this equation into constant coefficient equation. Okay, this is the first step. First step is we have to convert this equation into constant coefficient equation. Okay, how? The process is, for this type of problem, first you have to change the variable. So solution, you have to change the variable. Actually, this equation, we can write this equation in this form, that the given equation can be written as we can write in this form, that x square d2 plus 4xt plus 2 into y, this is equals to log x. Yes or no? Obviously you can see that the right hand side, this is non-homogeneous, so obviously you have to find out both complementary function and particular integral. So first step is you have to change the variable. Here in place of x square, 4x, in place of these variables you have to write some constant numbers. That's why we have to put x equals to e to the power z. This is the process. You have to put x equals to e to the power z, that is z is equals to log of x. Okay, so you have to put x equals to e to the power z, that means z equals to log x. So if you put x equals to e to the power z, now you have to convert the given differential equation. Actually, you have to write in place of xd, this is x square d square, na? So in place of xd, you have to write d dash. What is d dash? D dash, this is nothing but d dz, because I am changing the variable. So capital D, this is ddx. Capital D, this is ddx. Since I am changing the variable, that's why I am writing d dash, and d dash, this is nothing but d dz. So xd, that will be d dash. Okay. Similarly, x square d2, that will be d dashed into d dashed minus 1. Actually, I can explain how this how you are getting this d dash into d dash minus 1, but in that case the video will be lengthy, no need to explain these parts. Just calculate, just you have to write in place of x square d2, just you have to write d dash into d dash minus 1. Suppose the equation is cubic equation, or you can say 3-order equation. So suppose x cube d3. Okay, so in that case you have to write d dash into d dash minus 1 into d dash minus 2, and so on. Okay, in this way, but you will get only two variable, 2-order, so I am not explaining it. Okay, so in place of xt you have to write d dash, and in place of x square d square you have to write d dash into d dash minus 1. So the given equation 1, so 1 can be written as so this is equals to, you are getting d dash into d dash minus 1 in place of x square d2, okay, plus 4 into xt means d dash, so 4 into d dash plus 2, okay, into y. This is equals to log x, right hand side is log x, and log x equals to z, so this is equals to z. Just I have changed the independent variable x, I have changed the independent variable x to variable z. Now in this equation, suppose this is equation number 2. In equation number 2, the independent variable is z and dependent variable is y. Now if you simplify this, so you will get d dash square minus d dash plus 4d dash, that means plus 3d dash plus 2 into y. This is equals to z. Here you can see, suppose this is equation number 3. Here you can see this is the differential equation which we have solved in lecture number 1, 2, etc. Okay, here you can see the coefficients are constant number, dependent variable is y, and independent variable is z. Now easily you can solve this equation using complementary function, particular integral concept. Okay, so d dash square plus 3d dash plus 2 into y, this is equals to z. Now what will be the auxiliary equation? Directly write the auxiliary equation, or you can write the trial solution also. You have to write, let y equals to e to the power mz be a trial solution, because here the independent variable is z. So let y equals to e to the power mz be a trial solution. Okay, let y equals to e to the power mz be a trial solution. Then the auxiliary equation is just you have to write m in place of d dash, so this will be m square plus 3m plus 2, m square plus 3m plus 2, this is equals to 0. Now just solve this equation, so you will get m square plus 2m plus m plus 2 equals to 0, or you are getting m plus 1 into m plus 2, this is equals to 0, or m equals to minus 1 minus 2. Here m equals to minus 1 and minus 2, obviously this is distinct and real roots, so what will be complementary function? Yc equals to, remember here independent variable is z, so obviously the solution will be in z variable. Okay, so c1 e to the power minus z plus c2 e to the power minus 2z, where c1 c2 are arbitrary constants. C1 C2 are arbitrary constants. Okay, this is your complementary function yc. Now you have to find out yp, so particular integral yp is equals to 1 by d dash square plus 3d dash plus 2, okay, into what was the right side? Here right side is z, yes or no, because I am solving equation number 2, so right side is z into z. So this is equals to, obviously this is polynomial, and I have told you if it is polynomial 1 by f of d capital X, if capital X is polynomial, just you have to inverse it. So f of d inverse capital X. So just take common the constant number. So half into 1 by 1 plus d dash plus 3 d dash divided by 2 into z. So you are getting half into 1 plus d dash plus 3 d dash divided by 2 whole inverse into z. Now if you simplify this, half into, you are getting 1 minus x, that means 1 minus d dash, sorry, this is d dash square, d dash square, d dash square plus 3 d dash divided by 2. Okay, now in next term plus dot dot dot, in next term the term will be square na, 2 order, but here z is 1 degree polynomial, so obviously 2 degree polynomial will be 2 degree derivative will be 0, so I am not writing the 2 degree terms into z. So this is equals to half into 1 into z, this is z, minus d dash square. D dash square means double derivative, and double derivative of z, that will be 0. So plus minus minus 3 by 2, 3 by 2 into d dash z, d dash z means 1. So this is the particular integral. So you are getting half into z minus 3 by 2. Okay, so this one is complementary function and this one is particular solution, but this is not your solution, complete solution. What is the complete solution? Y is equals to yc plus yp. So this is equals to c1 e to the power minus z plus c2 e to the power minus 2z plus half into z minus 3 by 2. Now, is this complete solution? No, because our given differential equation, in given differential equation, the independent variable is x. But to make our calculation easy, or you can say according to Cauchy Euler method, we have changed the variable x to the variable capital Z or a small z, okay, to the variable small z. That's why the final answer, in final answer, we must have to change the variable z to the variable x, because x and y, this is our original variable. So this is equals to, now what is e to the power minus z? Here you can say e to the power z equals to x, na? E to the power, sorry, e to the power z equals to x. So what will be e to the power minus z? Just 1 by x. Yes or no? So in place of e to the power minus z, we can write c1 by x. Okay, or you can write c1 x inverse. Okay. Similarly, e to the power minus 2z. E to the power minus z equals to, you are getting x inverse. So e to the power minus 2z, that means square, na? So this will be x to the power minus 2. And x to the power minus 2 equals to 1 by x square. You can write x to the power minus 2 or 1 by x square, any one. So plus c2 by x square plus half, and what is the value of z? Here z is equals to log of x. So log of x minus 3 by 2. This is your final solution. Okay, so y is equals to c1 x inverse plus c2 x to the power minus 2 plus half log x minus 3 by 2. This is the final solution. Okay, let's try another problem. Solve x square d2y dx2 plus x dy dx plus y equals to log of x sine log of x. Okay, log of x sine log of x. Solution. Method is same. So first of all, we can write this equation in this form, that x square d2 plus x d plus 1 into y, this is equals to log of x sine log of x. This is, let's say, equation number 1. Now we have to change the variable. So let x equals to e to the power z, that is z equals to log of x. So equation number and also x d, we can write x d equals to d dash and x square d2, this is equals to d dash into d dash minus 1. Okay, so equation 1 changes to, so in place of x square d2 we have to write d dash into d dash minus 1 plus d dash plus 1. Okay, into y, this is equals to log x into sine log x. Okay, log x into sine log x. And what is log x? Log x means z, na? Here you can see log x means z, so you can write z into sine z, yes or no? Z into sine z. Now just simplify this, so you are getting here d dash square minus d dash plus d dash cancel plus 1 equals to, acha, this there will be y, this is equals to z sine z. Okay, let's say this is equation number 2. Now you can see here the coefficients are constant number, so now simply you can find out yc and yp. So let y equals to e to the power mz, because here the independent variable is z, so e to the power mz be a trial solution. Trial solution. Okay, then the auxiliary equation is m square plus 1, this is equals to 0, or you can see m equals to plus minus I. If m equals to plus minus I, then what will be the complementary function? Yc equals to c1 cos of z plus c2 sine z. Okay, this is your yc. Now what will be yp? Yp, this is equals to 1 by d dash square plus 1 into z sine z into z sine z. This is equals to, this is the last rule, na? Polynomial is multiplied with another variable capital V. That was the last rule of particular integral, z into sine z. So what was the formula? The formula is just you have to write z minus 1 by d2 dash square plus 1 and derivative of ft. On numerator you have to write derivative of ft, so this will be 2d dash, okay, into 1 by d2 dash square plus 1 sine z. Okay, let me write the formula again. If the right hand side 1 by f of t, x into v, if this is in this form, then the particular solution will be x minus f dash t divided by f of t, okay, into 1 by f of t into v. This is the formula. Okay, I have written this. Okay, now let's calculate. This is equals to, so z minus 2d dash divided by d dash square plus 1. Now in this part, this is sin z, that means trigonometric number, and in trigonometric case we have to write minus a square. In place of d2 we have to write minus a square. Here a is equals to 1, that means we have to write minus 1, and if you write minus 1 you are getting 0 on denominator. So what is the process? Just you have to multiply and then you have to derive the denominator. Okay, so just multiply, so you will get z into 1 by derivative of denominator, so this will be 2d dash into sine of z. Okay, so this is equals to z minus 2d dash divided by d dash square plus 1 into, here you are getting z by 2 and 1 by d dash sine z. Actually d dash means derivative, so what will be 1 by d dash? 1 by d dash means integration, and what is integration of sine z? Integration of sine z equals to minus cos z. So you are getting z by 2 into minus cos of z. Okay, z by 2 into minus cos of z. Now you have to simplify this. So finally you are getting pi equals to, from here, z minus 2d dash by d dash square plus 1 2d dash by d dash square plus 1, and from here you are getting minus z by 2 into cos of z. Okay, minus cos of z. Okay, so now break these two parts. So first z into this, so you are getting minus z square by 2 cos of z. Okay, minus minus plus, plus half into 2d dash divided by d dash square plus 1 into z cos z. Here 2 cancel, so you are getting minus half into z square cos of z plus d dash by d dash square plus 1 z into cos z. Okay, now here you can break this part. In numerator this is d dash, and in denominator this is d dash square plus 1, and according to numerator d dash into z cos z, that means derivative of z cos z. So you can write minus half z square cos of z plus 1 by d dash square plus 1 into d dash of z cos z. Yes or no? Clear? D dash of z cos z, d dash means derivative of z cos z. So this is equals to minus half z square cos of z plus 1 by d dash square plus 1. What is the derivative of z cos z? Derivative with respect to z, so this will be cos of z minus z sine z. This is the derivative. Okay, so this is equals to minus half z square cos of z plus 1 by d dash square cos z. That means again you are getting the negative 0 terms in denominator. So 1 by d dash square plus 1 cos of z minus 1 by d dash square plus 1 z sine z. Now simplify this part. Here a equals to 1, so in place of d dash square if you write minus 1, so again you are getting denominator 0. Okay, that means this is equals to minus half z square cos of z plus you have to multiply z into derivative of the denominator, that means 2d dash, z into 2d dash into cos of z. Okay, Now minus next formula, z multiplied by sine z. Okay, so here you are getting z multiplied by sine z. So the same formula I am using, z minus actually this is z multiplied by sine z. Actually this is pi na. I have started the calculation from here, 1 by d dash square z sine z. That means I am getting the same part here, 1 by d dash square z sine z. Yes or no? I have started from here calculation. So in place of 1 by d dash square plus 1 z sine z, you can write yp. So you are getting minus p into I. And left hand, we have the left hand side as pi equals to this. So if I take this pi to left hand side, so you are getting 2 p dot I. This is equals to minus half z square cos of z plus half z 1 by d dash cos z. That means integration of cos z. So this will be sine z. Okay, so finally you are getting 2 into pi. This is equals to minus half z square cos z plus half z sine z. So what is pi? Pi is equals to minus 1 by 4 z square cos of z plus 1 by 4 z sine of z. Okay, so what is the general solution? So the general solution is y is equals to yc plus yp. So this is equals to, what was the yc? c1 cos z here, c1 cos z plus c2 sin z, c1 cos of z plus c2 sin of z. Okay, minus 1 by 4 z square cos of z plus 1 by 4 z sin of z. But this is not the final answer, because in question our original variable is x and y. So we have to convert the z variable to x variable. Okay, you have taken that z equals to log x now. If x equals to e to the power z, so z equals to log x. So in place of z, you have to write log x. So you are getting c1 cos of log x plus c2 sine of log x. Okay, minus 1 by 4 log of x whole square cos of log x. Okay, plus 1 by 4 log of x into sine log of x. This is the final answer. Okay, this problem is quite difficult and quite lengthy problem, but you have to solve this type of problem. Okay, you will get at least one question from this topic, Cauchy Euler method. Okay, thank you so much. I think this method is now very clear to you. If you have any doubt, you can ask me on my WhatsApp number. Thank you so much.